Okay, class, we're going to do 11.1, graphing square root functions. Okay, so this is a radical. You can see it's under a square root. And we're going to start with the basic parent function. Just like you had a parent function for quadratics, you have a parent function for the square root. So a basic one is y equals square root of x. You can see it right here. Just make it a little darker. That is the parent function. Okay, so what do we know about numbers under a square root? Can they be negative or just positive? So hopefully you're going to tell me they have to be positive. So that is the beginning number that we're going to start, the first x value. So can we have 0? Yeah, the square root of 0 is 0, that's fine. But we cannot have -1. We can't take the square root of -1. Not for graphing, okay, at this point. Obviously, as you get more advanced and stuff, there's other ways to do it. But for right now, you can't. So the smallest number that you can start at is 0, okay, for x. So then if I plug it in, the square root of 0 is 0. So 0, 0 right here is my starting point. I cannot go past that. Okay? Then with square roots, you want to pick numbers that work out nicely. So you don't want to have decimals if you can help it. So 1 is a perfect square. So if I plug in the square root of 1, I get 1. The next x value, so they put 1, 1 here. So I do another one just to show you. So obviously I'm not going to pick 2 for x because the square root of 2 is not a nice number. It's a decimal. I mean, you can use it. So the next perfect square is 4. So if I plug in 4, the square root of 4 is 2. So if I go loud 4, 2, that is also on here. So you can see that it has this form right here, and you put your little arrow because it's going to be going on forever. Okay, so that is a basic square root function. So we have learned about shifts and stuff, so this is what we're going to do. We're going to be shifting and seeing how we can change it. So here we go. Graph a function of the form y equals a to the square root of x. So they want you to graph y equals 3 to the square root of x and compare it to the graph y equals square root of x. Well, we've already done y equals square root of x. We know we have 0, 0, 1, 1, 1, 2, 3, and we have 4, 2. So it's just like the parent function for the quadratic. Once you got those numbers down, you don't have to keep doing them. You have them up here. But I'm going to go ahead and show how we get the numbers for the new one. Y equals 3 to the square root of x. I want to use those same numbers because they're perfect squares. Again, it can't start past 0. So if I plug in a 0, 0 times anything is still 0. So 0, 0 is where the new one starts. They start at the same point. Now I'm going to plug in a 1. So here I've got y equals 3 times the square root of 1. So the square root of 1 is 1. 1 times 3 is 3. So instead of having 1, 1, which the original, you can see it's stretching it to 1, 3. So here we go, 1, 3 is the new point. Then I'm going to pick 4. They might have done decimals. I'm going to go ahead and just jump to 4 because I know it works out well. So now I'm putting y equals 3 to the square root of 4. So the square root of 4 is 2, and 3 times 2 is 6. So 3 times 2 is 6. So when I go to 4, 1, 2, 3, 4, I should go 1, 2, 5, 6, and here it is. So you don't need to do a ton of them. 3 is good. Do the arrowhead because it means it's going on. So this is where I need you to pay attention because now we're going to be doing domain and range. And it takes a little practice. So we know, I've mentioned this before, and some of you guys struggle a little bit with it. Domain are the x's, okay? And range are the y's. So x's go side to side. That's what you need to think. And y's go up and down, okay? So let's go ahead and write the domain and range for this original function, okay? And it will always be like that. The parent function will be like that. Once you have it, you got it. So for the original, I'm running out of room here. Let me write it here. The domain is going to be from 0 to infinity, right? Because it's going to keep going along the x values forever. So it starts at 0, so I include 0. So I put a bracket, not a parentheses. Parentheses mean you don't include 0. So you can say 0 to infinity. I can write it like that. Or you can say the domain is all number greater than 0. So however you want to do that, you can write it like that, okay? So x's are greater than equal to 0. Okay, you're including 0. The range, okay, again, here starts at 0, and though it's slowly going up, it's going to get higher and higher. So the range is the same thing. You can write it 0 to infinity, or you can say the range is all numbers greater than 0. You can even write it out as all numbers greater than 0. Okay? It depends what you want to do. Hold on. Let me make sure you can see this very clearly. Okay. Hold on. I moved it a little bit too. Okay, there we go. That's what I'm trying to do. Okay, so the domain and range are going to be from 0 to infinity. All right? So the new one, does the domain and range change at all? The domain and range both start at 0. Are they going to go in the domain forever and then in the range forever? Yes. So even the new one doesn't change. The domain and range is going to be from 0 to infinity. So they wrote it, the range is y is greater than or equal to 0. They wrote it this way. And the domain is the same thing as x is greater than or equal to 0. Okay? So right here you can see. So that does not change because it really hasn't shifted. All it did was stretch it. So if it stretches, it doesn't really change. It's when it starts shifting that we're going to see. So let's do an example where we see some shifts here. Okay, before we do that, I'm going to touch on one where it has a negative, okay, because we want to see the difference with a negative. So you can see I've got a negative at 0.5, which is the same as that. So my new is negative 0.5 square root of x. So we always do the original function. We know it's 0, 0, 1, 1, and at 4 we have 2. So it's just like the quadratic. You have that written down, memorized. You don't have to keep figuring it out. Just reproduce it once you have those numbers. So now we're going to see what a negative does, and we can see here the negative is going to go underneath. It has to change. So let's go ahead and plug in those same numbers. I'm going to pick 0, we're going to pick 1, and we're going to pick 4. Now they picked a lot more. I'm not going to do as many. If I plug in 0, 0 times negative 0.5 is still 0. So you can see it's still starting at 0. If I plug in 1, the square root of 1 is 1. 1 times negative 0.5 is going to be negative 0.5. And you can see they have it here. Okay, then I'm going to put the square root of 4. The square root is 4, and 4 times a negative half is going to be negative 1. So that's a 0. Okay, so I just did the 3. Not doing the decimals in between. I mean, you can figure it out in a calculator. That's fine. So 0, 0, negative 1, and negative half. And then at 4, we all go down to negative 7. Okay, so there we go. We have our graph. All right, and it's headed down like that. Okay, the difference now is the domain and range. So the domain, so look at the graph because that helps you. Starts at 0. So this is the domain. This is the easiest way to tell the domain and range. Look at the points that you're plotting. It's going from 0, 1 to 4, so it's increasing. So they wrote the domain is x is greater than or equal to 0. Okay, but my y's, Are they going up or are they going down? Here they're going down, so it's the other way around. And see how they've written it? Looking here, making sure I'm lining up. Okay, I don't know where. All right, so we would write it 0 less than or equal to 0, so it'd be the other way around. Okay, so the y's are going down, they are not going up. So look at your graph. That is really the easiest way to read. Okay, the range is y is less than or equal to 0, so that's what I was looking for, because I'm doing it as I go along here, so I haven't looked before, and the domain is here. Okay, so you can see that that is the easiest way to write it, and the easiest way to look is plot the points and look, are they increasing or are they decreasing? That tells you it's going to be less than 0 or greater than 0, or whatever number. So here we're going to do a couple shifts. Okay, so here we have one, y equals square root of x plus k. So even all these shifts are the same on any graph. If I have a plus or a minus on the outside, what does that do to the graph on a quadratic? If I had y equals x squared minus 5, what did the minus or the plus do? It moved it down or it moved it up? It's the same thing here. This is just going to add 2 to it. It's going to move it up 2. So here's the new one, and we're comparing it to the original. We know the original looks like this, okay? So it takes nothing to reproduce it. You know the numbers to plug in. We're going to plug the same numbers. I'm going to go over here and plug a 0, and we're going to plug 1, and we're going to plug 4, just like we did. So if I plug in 0, but now I'm adding 2. So at 0, I'm at 2, and that makes sense because we know it's shifting up 2. So instead, the original starts at 0, 0. The new one shifts up 2. You take every point and you shift it up 2. So where the original was 1, 1, the new one should be 1, 3. And let's see. Square root of 1 is 1. 1 plus 2 is 3, just like I said. So when we plugged in 4 in the original, we got 2. If we shift it up, we should get 4 and 5. So the square root of 4 is 2. 4 and 4. It goes up 2, not 3. Square root of 4 is 2. 2 plus 2 is 4. So there we go. 2, 3, 4. Okay, so here we go. Here is the new shift. If we went down, it said minus 2, you would go down 2. Okay, so you're going to have to practice a little bit on your graphing paper, and the more you practice this, you'll get the hang of it. We know the domain and range of the original. Let's practice the domain and the range of the new. So I'm looking here. The domain starts at 0 and it increases. Okay, so we know that it goes this way. So the domain is going to be x is greater than or equal to 0. Just read here. The y starts at 2 and it increases. So now the y is going to be greater than or equal to 2 because it's starting at 2, not 0. Honestly, reading it from the graph is the easiest way to do it. You can see it, you can understand it, and it should be much easier. All right. We're going to do a couple more shifts. Let's go ahead and do a shift within, okay, the square root. So it's not on the outside, so it's not a plus or minus on the outside. So it's not going up or down. If I have a shift inside the square root, it's either going to the left or to the right. So we know the original is right here, okay? The new one that they want us to graph is the square root of x minus 4, okay? So the starting point, take whatever is inside that function, and this is how you'll find your starting point. Set it greater than or equal to 0 and just solve it. So it is the opposite of what it looks like. So it's going to start at 4. So here's the original, 0, 0, 1, 1, and then you got your 4, 2 up here. So this is your original. So this is moving 4 this way. So that is the shift when you go inside. You're either going to go to the right or to the left. If I had a plus 4, when I go ahead and solve it, it would go back 4, okay? So I'm going to put my x and y's. My beginning x is 4, okay? So when I plug in 4, 4 minus 4 is 0. So I get 4, 0, which is right here. Again, I want to pick perfect squares. What's the next perfect square? Isn't it 9? So if I plug, well, actually, I want it to become 9. So if I plug in 9 minus 4, I get 5. So I don't want to use that. So what number can I plug in for x that will make a 9? Wouldn't it be 13? 13 minus 4 is 9. What's the square root of 9? It's 3. So I've got 13 and 3. So you can see that this goes on like this. Okay, 13 and 3. And the next perfect square is 4. So that would have to give me a 16. So what number minus 4 gives me 16? That would be 20. 20 minus 4 is 16. The square root of 16 is 4. So you can see you have to just go a lot further in the x direction. And it's going to go kind of slower in the y. Okay? So that is your new graph right here. Shifted over 4. Every point shifted 4 this way. Okay? So we are going to find the domain and range. That's what you need the practice on. So the domain is starting at 4 and it's going up. So x is greater than or equal to 4. That's the domain. The range is starting at 0 and it's going up, it's increasing. So y is greater than or equal to 0. And that's how you figure out your domain and range. So think about, you want to make perfect squares. If you don't, you can use a calculator, that's fine. You can plug in any number you want. They chose to do 4, 5, 6, 7, 8. I chose to make perfect squares. It doesn't matter. You're going to get the same graph. Mine's just going to be stretched out a little bit more. So whatever you want is perfectly fine. Last one I'm going to do is a shift of both kinds where it stretches and it goes down 1. Okay? So again, you're looking at the original. Actually, they want you to compare it to 2 to the x. Okay? So we can. Sorry guys, I'm just responding to someone in Teams. Okay. So the graph of function y equals 2, square root of x plus 4 minus 1. So you can see there's going to be a shift here, there's a shift here, and there's a stretch here. Okay, so sketch the graph of y equals 2 to the x. Okay, so let's look. So we've done that earlier. We know that we got 0, 0. If we plugged in a 1, we would get 2. Okay, because the square root of 1 is 1. 1 times 2 is 2. Then I'm going to plug in a 4. Square root of 4 is 2. 2 times 2 is 4. So 0, 0, 1, 2, and 4, 4. Thank you. Okay, so that is the one they want you to compare. So the new one, it's going to stretch, it's the same stretch, but here it's going to be changing to the left and going down 1. So let's go ahead and do this. Y equals 2. You just take your time, and as you do these things, and make sure you write the minus 1 on the outside. Got to be crystal clear in math. It can be under the square root because it's not. So that means I'm going to go down 1, and x plus 4 is going to be the opposite. I'm going to shift to the left 4. So let's go ahead and find where we're starting under the square root, okay? So take x plus 4 is greater than or equal to 0. Subtract 4. X is greater than or equal to negative 4. So I'm going to do my little t-chart, which I've taught you. We are going to start at negative 4. Okay, that's our starting point. Whatever under the square root, that's your starting point. Okay, so you go and you say negative 4 plus 4 is 0. 2 times 0 is 0. 0 minus 1 is negative 1. So that is my starting point, okay? And here it is, -4, -1. All right, and we can see that it's going to go up. So the next one, we want a perfect square if possible. The next one to give us a perfect square is, let me see, -1, as or to give us a perfect square, not necessarily the next one. I'm going to go ahead and I'm going to use 0, because I know 0 plus 4 gives me 4. The perfect square of 4 is 2. 2 times 2 is 4. 4 minus 1 is 3. Okay, so at 0, I go to 3. Okay, so then after that, what's the next number I can plug in for x to give me a perfect square? So 4 plus 1 is 5, that's not 4 plus 2 is 6, 4 plus 3, 7, so it's going to be 5. So that's how I'm doing it. It doesn't matter. You don't have them right. You don't have to have them right next to each other. So 5 plus 4 is 9. That's my next perfect square. Square root of 9 is 3. 3 times 2, you have to multiply first. 3 times 2 is 6, and 6 minus 1 is 5. So if I'm going here, 5, 5, so there we go. As long as you got 3 points, you can have them right next to each other, you can spread them out. So this is, so as you do it, you'll get more practice. The big thing now is domain and range. So domain, x, it goes from -4, 0 to 5, so it's increasing. X is greater than or equal to -4. And then the range is y, it's going -1, 3, 5, so it's increasing. It's greater than or equal to -1. Okay, so you can see that it is increasing. All right, guys, go ahead and practice and watch. If you want to watch other videos I've attached, that's fine. And I'll talk to you soon. Bye-bye.